In this part, I'll look at IPv4 addresses. Despite the fact that IPv6 networking is now accessible and being used, IPv4 networking will continue to exist for a very long time. In this video, I will first discuss what IPv4 is, followed by an explanation of what an IPv4 address is. It is critical to comprehend what creates an IPv4 address. They launched IPv4 when it was originally developed. The concept of classful networking. Even though this concept has become depreciated over the years, it is still important to understand how it works to have an understanding of IPv4 version. I'll then look at the subnetting procedure. Subnetting is the process of separating a big network into smaller pieces. Finally, I'll have an examination of private addresses. Private addresses are IP addresses that you can allocate however you see fit. You see suitable within your company. The fourth version of the IP is the IP protocol. It is the default protocol for the Internet and by far the most popular protocol in use today. Version 5 of the IP protocol was never implemented by the Internet, but IP version 6 is now being utilized. Nonetheless, IP version 4 will be in use for a long time. Time is approaching, thus it is critical that you grasp the process. Consider the following to learn how the IP version 4 protocol works. The IP protocol and the TCP protocol combine to give a comprehensive network solution. TCP is in charge of keeping messages alive in order and retransmission of data when it is lost, but the IP component is just responsible for transporting packages from one site to another. IPv4 addresses are 32 bits in length. To facilitate reading, they are broken into 4 octets of 8 bits separated by dots. As an example, 192.168.0.1. An IP address identifies your computer and allows other computers to communicate with it. Yours. Consider it like a phone number. Telephone numbers have area codes, although IP addresses do not. Addresses have network IDs to help separate and organize your network into logical parts. Initially, all networking was classified. These classifications ranged from A to E. The number of computers that could be on the network was regulated by the class. These networks may be subdivided into smaller portions through a technique known as subnetting. Version of IPv4 since it was originally introduced has been improved and developed. The system of classes imposed constraints on how networks might be created. Classless networks have since been added. It allows you to alter the design of networks. They introduce a mechanism known as supernetting. Enables the combination of many networks. I'll look at any of these aspects individually, but let's start with class networks, often called as classful networking. Originally all IP addresses were allocated according to a class. The class used defines how many hosts may be deployed on this network. Today, classless networks are more frequent, which I shall discuss later. The remnants of classful networking still exist today and often used in the discussion. It is a vital issue to understand in terms of networking. The first class, Class A, may accommodate 16,777,214 hosts. These are offered on 126 different networks. The network and host IDs must not include entirely zeros. For a loop back, the 127 network is inverted. You are pinging your local machine if you ping any addresses in the 127 network. This is being used for testing. For a broadcast, the last host ID or a host ID with all ones is inverted. The next class is called Class B. This class has 16,384 networks and 65,534 hosts per network. As you can see, both classes A and B have a large number of hosts per network. The initial system allocating IP addresses based on class resulted in a large number of unused IP addresses. The Class C network has 2,097,152 networks, each with 254 hosts. This is a network, better ideal for smaller networks, although as you can see even with 100 computers, there are still a lot of unused IP addresses on a network. For multicast, Class D is flipped. You may deliver a single packet to several machines using multicast. Class E is the final class. This class has been inverted and is no longer in use. Using Classful Networking generates a large number of unused IP addresses. To make use of the address, subnetting might help you save space. Subnetting allows you to divide a network into segments, into tiny pieces. It is also used to distinguish which traffic is local and which traffic is not, is for a remote network. Unfortunately, once you start subnetting your network, you must begin functioning in binary. Consider the following scenario to demonstrate how subnetting works. As the IP address, subnet mask, and destination IP address are shown in binary. When the subnet mask is shown in binary, it is clear that it is a continuous list of ones. Then a string of zeros. Ones must always be on the left and zeros must always be on the right, because the subnet can be represented by the IP address / number of bits. If I were, it would be necessary to use / notation to display the IP address and subnet mask indicated in the example. B192.168.10.100/24, as there are 24 1 bits in the subnet mask. The subnet mask is used to determine if the traffic is for a remote network or the local network. The bits from the IP address and the destination address are compared to accomplish this, but solely in relation to the subnet mask. The subnet mask in this case is 24 bits. As a result, the first 24 bits of the IP address are compared to the destination IP address. If they match, as they do in this example, the packet is forwarded to the local network. You could be thinking that I could just glance at the first 3 octets of the IP address and figure it out. To determine whether they match the target IP address in this scenario, the answer is yes, because the subnet mask is a simple one. The idea behind subnetting is you can take a larger network and reduce the size of the network. If I changed the subnet mask to the following, the subnet is no longer as easy to figure out. I've now partitioned my network by utilizing this subnet. I divided my original network into 14 smaller networks, each with 14 hosts. Network, in other words, I have allocated 4 bits of the host address to the network address of the IP address. If you take the same example, compare the subnet mask against the IP address and the same destination address, you receive the following when you enter your IP address and destination address. As you can see, the first 4 bits of the last octet do not match. Because they do not match, this packet will be forwarded to the default gateway because it is not for the local network. As you can see, subnetting provides a lot of flexibility and power for breaking down bigger networks. Smaller ones. The trade-off is that you need to start doing some binary operations.